in the session. We have a good number of participants joined online for the session on energy efficiency in auxiliary equipment. Mr. Umar Shankar Chowdhury is the unit head of JK Cementech. He is going to be a session chairman for this, and he is going to introduce the participants, and he is going to introduce the speakers for the sessions one by one. And then I think you can present technologies to the participants. Yes, sir. Over to you, Mr. Umar Shankar. Can set a classes for the session and start. Thank you, sir.
Thank you, Saurabh. This is a great initiative by CIA that this online virtual conference for today. And as we all know, the theme is preparing for a net zero carbon future. So today we are here to join for the energy efficiency improvement for auxiliary equipment. As today the great faculty with having with us, the first thing what is the auxiliary power? The auxiliary power is the essential power used by the auxiliary equipment. And energy efficiency in auxiliary equipment is one of the key area, but generally it doesn't so much attention. Generally, more attention is the high consumer power. But the requirement is to, when we are optimizing our plant or our any system, we have to focus for all the system and all the small power consuming. So this auxiliary power consumption can be reduced by improving the plant load factor, by operational optimization, by adoption of advanced control technique and implementation of energy conservation measure. And we know there is in all industry, there 5 to 10% role of the auxiliary equipment. And mostly we are focusing on major energy, but we have to give more attention. And today there is more energy efficient equipment available in the auxiliary category. Lot of equipment available, and many of them are getting presented by this forum itself. So we can proceed. First, I will invite as Saurabh Chaudhary ji here for the National Sales Manager, Atlas Corpoco India Limited. So first we have to know about the reducing operational cost in compressed air system. Then we'll go with the Rohit Sharma ji, and then again for the Reach India as well as Turbo India. And after that, we'll take the question answer. Then we can close the session. So now over to Saurabh ji, as you have already joined before time with me. So you may take the lead, and you have to elaborate about your as operational cost in compressed air system. This is very much beneficial for the present context for the all industry. Now we all are eager to listen from your side.
Thank you so much, sir. Thank you so much, Umar Shankar ji. I hope I am audible. You can hear me. Hello.
Yes, sir.
Am I
You are
audible,
audible.
sir?
Yeah,
Okay.
you are audible, sir. Please go ahead.
Okay. So I'm going to share my screen. Just allow me a minute. Just let me know if my screen is visible.
Visible.
Visible, right?
Yeah. Make it full screen. Thank you.
Yeah. So first of all, thanks to CII for giving us this platform to come and share our innovative ideas on energy savings, because that's the need of the hour, as rightly said by Umar Shankar ji, that we are all striving towards carbon neutral society, carbon neutral organizations. So how can Atlas Copco contribute? That's the discussion. I'll keep it very short and brief for discussion. We'll start with a very brief introduction of Atlas Copco, who we are, what company we come from. Many of you might be knowing us, but still we'll keep it a very short introduction. Then we'll straight away go into the applications, and specifically we'll discuss on the low pressure compressed air applications, where we can help and contribute to reduce substantial energy savings, to save carbon footprints, and what we can see what's in future. And we'll also take it up a few questions and answers before concluding it. So we'll start off very quickly. Atlas Copco is a world company. It's started off in 1873. It's a European company. The head office is based in Sweden, but we have our presence almost in every part of the world. And broadly, it's based in 4 different business areas. So the biggest business area is the compressor technique business area. We are very proudly say that we are the largest compressor manufacturer in the world, and we have solutions for each and every type of the technology that we have. The only for the compressor technique, we have worldwide the production facilities across the world, starting from US, China, India. Also, we have 2 plants in Pune, and I'm based in that one of the plant only in Pune. So this is the 2 plants that we are talking about in India. One in Dapuri and one in Chakan. Both are in Pune. And we in India also, we are here since 1960s. So we are here more than 60 years in India. So with that, we come to the direct topic. So the discussion of the day. So whenever we buy any equipment, specifically a rotary compressor, if you do the analysis or the life cycle analysis of that, you will find that more than 75 or 80% of that cost is in the energy cost. Something is your investment will be 10 to 12%, and the rest is the maintenance. So all our things are here on this bigger pie of 76 to 80%. How we can reduce that? That gives the energy efficiency. That gives the overall advantage to the customers. Okay. And the why we should be doing it, because the reason is obvious, because energy is scarce and we have limited resources, and it will be sustainable if we can make it more energy efficient in the long run. Because over a period of time, things the resources that we have will be limited. We have the global warming issues also. So considering that in environment part also, we are in the right direction. We are thinking already in the terms of energy savings and wherever possible to those things. So from that, why this kind of things are coming up, and innovation is a part of the DNA of Atlas Copco. Every year we invest almost 5 to 6% of our overall revenue in R&D activities to come up with more and more energy efficient products. So how do we do that? We try to challenge our own selves. We try to make the products which are already efficient further efficient, and we're going to discuss a few of those in the subsequent slides, and how we can contribute and help the cement industry. So this is basically a very simple message, the mission that we have. We want to reduce the operating cost for sure, and we want to increase the uptime. That's the basic mission or the motto that we have towards cement industries. And what we have closely observed is that we try to map out all the application in terms of the operating pressure and the flow that is required. So if you see that we have various applications like pneumatic conveying, unloading from the bulkers, combustion air, fluidization of silos, where you need separate in the plant, be it a grinding unit or be it an integrated plant, there is a substantial requirement of compressor, and it plays a very critical role. So we'll take it up some of the critical applications, and we'll discuss what are the present things and how we can improve in future. Okay. So let's say a very critical application in cement is the pneumatic conveying, be it conveying from point A to point B or unloading of materials from a bulker. Maybe it can be a fly ash, it can be anything else. So what we have seen is that this can be airlift also. Okay. So what we have seen typically is that, let's say this is a bulker, and we have done a bit of a close study here. The bulkers are typically 30 to 40 tons, and they are typically designed from 2 to 2.5 bar. That means the bulker body cannot take more than this pressure. It is not safe to do that. Okay. So what we have seen when we have been doing this kind of a study, we have studied several bulkers. And what we have seen is when the compressed air is given, like there are two if I can go back to here, there are two connections here. In one connection, you hit the compressed air line, and in the other connection, the fly ash or the material which is there in the bulker moves out and it gets stored in a silo. So that's a very simple application. But what we have seen is that the bulker, when we are giving the initial resistance, the bulker is full of material, the resistance is high, so the pressure builds up. It doesn't go beyond 1.5 bar. That's what we have observed in most of the cases, and it remains stable for a while, and then as the material moves out of the bulker, the resistance decreases and the pressure comes down. So you can see the maximum pressure here is around 1.5 bar. This graph explains this very nicely. In the y-axis we have the pressure, and in the x-axis we have the time required to unload or empty the bulker. So here, one of the major observations is this, that the maximum pressure does not go beyond 1.5 bar. Now, when we see most of the cement plants, what we normally see here is this kind of application, we see a compressor like this, which is, let's say, a oil injected compressor, and normally at a medium pressure of around 4.5 or 5 bar or a 7 bar compressor, wherein it is being put into a kind of a common header, and then a tapping is being taken on which a pressure reducing valve, or commonly known as PRV, is being put to get the desired, the low pressure which the bulker can sustain around 2 or 2.5. But in doing that, let's analyze that. Let's say typically a requirement of 1,000 CFM. If you're operating this at 5 bar, because this oil injected compressors has a limitation, it cannot go below 4.5 or 5 bar, because that's how the design is, and this is how this is set up. It consumes around 158, let's say 158 to 168 kilowatts, closely. Okay. Now, if we can put a dedicated oil-free compressor, which is designed for low pressure requirement, let's say at 1.5 or 2 bar, the power consumption of the total power consumption would be around 85 to 88. So even considering it is 12 hours a day, this operation is not continuous. Maybe it's working 12 hours a day, considering 350 days as a working year. Roughly around 5,000 operating hours per year. Considering 6.5 as a unit cost, this is substantial saving of power comes down to around something close to 23 lakhs per year, which is quite substantial. Okay. So if you put it in terms of the carbon footprint, it's something close to 82.5 tons of carbon per year, which is quite substantial. So small things, just what we are suggesting here is dedicatedly have a separate oil-free solution for this, and it can give you a substantial savings in terms of power. Not only on the power, if you look on the overall consumables, because these are oil-injected compressors, it takes a lot of consumables in terms of oil filters, and others. So the difference in this will be somewhere around 2.5 lakhs. So if you add that up, if you totally add that up, the total operational cost as compared to oil-free with a dedicated low pressure, let's say at 1.5 to 2 bar, and oil injected, the operational cost per year would be close to around this much extra. So the extra investment that you're going to pay for oil-free will be paid back even 1 to 1.5 years, something like that. So it makes sense. So this is one of those applications where you can focus on this. Okay. So these are those compressors which are typically available from 55 kilowatt and as big as 750 kilowatts. So more than thousands of these machines are working various plants across India, across the world. It's a very successful, reliable, proven machine. Okay. Now coming to, these are all those plants which are already using it. Most of the plants in most of the leading cement plant manufacturers are already started understanding this, started using this. Okay. Now coming to other low pressure applications, wherein we have this kind of a situation wherein you have a fluidization effect to be done. So for wherein a typical low pressure less than 1 bar is required, it depends upon the height of the silo and the material that we need to keep it, the density of the material. So a certain amount of pressure will be required. Okay? So for that, we try to term that as a fluidization. So if not fluidized, then the free flow may be stopped like this. We normally call it as rat holding. We all know that. So to make that happen, there is a pressurized air goes into this application, and it allows the material to have a free flow. For that, we have various capacities of blowers. Like in screw solution, we have screw blowers which can go up to 9,000 meter cube. Beyond that, if the requirement goes for very big plants, we do have centrifugal blowers, and of course the low. But we are concerned about this now. In the low blower, these are the typical, the twin or the tri-low blowers, which are in multiples in every cement plant. And these are normally taking care of this fluidization, also some of the combustion here, what we normally call as a kiln firing application. Now, if we have a close look here, let me explain the technology with a bit of animation here. I hope you can see the screen. So in this, if you see this is how a lobe or a tri-lobe machine operates. So this is the principle of it. Basically, it's a displacement device. It's basically displacing the air from the inlet port and the outlet port. There is no internal compression happening. Since there is a resistance at the discharge end, there is a blockage at the discharge end, the pressure rises at the discharge. But if you remove the resistance there is no internal compression. So as we know that air always has a tendency to go from the higher pressure to lower pressure side. So as a discharge end, when the air is getting trapped, it is at a higher pressure. So some of the air always has a tendency to leak back to the section. So these kind of machines has always a leak back. That means whatever is the theoretical value being mentioned, it's not being delivered at the outlet. Higher the pressure, higher the leak back. So that's one thing. And second thing, it is a external compression device. As compared to a screw here, you can see wherein the air is actually getting trapped in the male and female profile of the rotor. That's the design of it. And it's actually getting internally compressed. So as a result, it's more closer to adiabatic. So it has an internal compression. The pressure ratio can be designed. So if we are let's say are designing a blower of 0.8 or 0.9, then it's actually an internal compression. So when we see the results, at least theoretically, you will see that if you plot this in the form of a P and V curve in thermodynamic studies, then we all know the area under the PV curve becomes the work done. Okay? So if you see, this is how typically a twin lower tri-lobe P and V curve will look like. What changes happens in the screw is that the suction remains same, the compression being internal. We have a savings in this portion. The green portion in the curve basically shows the savings. So when we actually manufacture, since we are manufacturing both these blowers, we actually tested this blowers and we tested at various pressures for same flows with variable frequency drives. So what I want to show you or highlight is a major thing that needs to be considered. That if you're operating a low blower at 0.5 bar and that same can be replaced by a screw blower, you can see the difference in the energy consumption close to 24 to 30%. But if the operating pressure is higher, let's say at 0.8 or 0.9 bar, you can see the difference goes even to 40%. That is substantial. The 40% in difference in energy is substantial. So one such application which is very common in cement is the burner or the kiln firing application, wherein the pressure is really close to 0.8 bar and you need a big amount of air. As it can go as low as 3,000, it can be as high as 5,000, 7,000. So we have done some analysis for that. Let me show you. So this is an application where the air is used for the burning. It's a critical application. It has to operate 24/7. It cannot stop. If it stops, the kiln also stops. So let's say we are talking about a 5,000 meter cube 0.9 bar application. The existing tri-lobe machines is with a 250 kilowatt motor. Now that same can be replaced with a 132 kilowatt screw blower. So if you see the difference here is mentioned here. I will not go line by line, but the basic thing I want to show you, the graph here shows the range of the operation of the flows. You can see the minimum flow is as low as 1600 meter cube. It can go as high as to 55,600 meter cube. So just let me set the pointer here so from 1600 meter cube to 5,600 meter cube, that's a wide turn-down range that we have. And let's say we are trying to operate around 4,000 to 5,000. That's the operation range. So at 4,000, the operation the power consumed is only around 103 kilowatts, whereas the existing is somewhere around 165. When you do the difference in the total package power, the overall difference comes out to around 83 kilowatts, 84 kilowatts, which is quite substantial because this blower is operating almost 24 hours a day, every day of the year. So when you do it even with a modest 6 rupees per unit calculation, a substantial saving of around 42 lakhs comes in. And so, and not only that, apart from that, it's a huge savings on the carbon footprint also. Almost close to 164 tons of CO2 emission can be saved if you can go with this kind of. So another application which we are now finding it quite common because we are seeing cement plants going for alternative fuels. And with the alternative fuels, because obviously that's the trend of the future. I think there are sessions today also where this kind of topics are getting discussed, which basically means coal is a limited source of fuel, and we need to, for sustainability, we have to go for alternate source of fuels. But with alternate source of fuels, what happens is that we do get some undesirable gases like sulfur, like chlorine, which not only pollutes the environment, but it also, deteriorates the quality of the cement. but that kind of gas has to be get rid of. So that kind of systems are normally called as sulfur or chlorine bypass system. So in that, the setup is something like this. I'm sure you must be aware of. For that, a bypass arrangement has to be made, and typically a demand of around 3,000 to 5,000 metric cubes at around 1.2, 1.5 bar amount of gas is required. Again, same thing, similar. Screw compressors, screw blowers can be of immense help. It can save up to 40% of energy as compared to the traditional file lobes and the clean lobes. Okay. So these are some of the installations you can see. These are some of the installations for photographs taken. So this will be such clean and most of it are governed by microprocessors which are connected, and it is with all the latest technologies, so you can get all the informations over a click of in your mobile. So overall, these are the blower portfolio that we have. We have blowers for almost all sizes and dimensions and the flow and pressure requirements. So this is what I was talking about. Everything you'll be getting over a click in the mobile, the performance, the running hours, how much energy is getting saved, all those informations will be made available. If that kind of technology has come. Okay. Now, what we can further do, we are already doing it in things. What we can further do is we do have the the expertise and we are here in this industry for more than 150 years. We have been studying cement, studying pneumatic conveying very closely. So we have also developed our expertise in calculating or designing the pneumatic conveying system. So what we are saying is that if you can give us some basic input details like the density of the material to be conveyed, the distance to be conveyed, the number of the bends that you have, and the mass flow in tons per hour. Okay, then we can come up with the exact calculations to show that okay, this is the flow and pressure that you require. So the most optimum the solution can be you might even end up in selecting a bigger or a higher pressure or a higher flow machine, which is actually not required. You can get into a much smaller investment, and we can actually save more money. So we can also do this as we have been taking these initiatives and been doing this, and we can also extend our support in calculating and helping you with these calculations for specifically for pneumatic conveying or unloading applications. So let's say you have, I'm just showing one of the sample cases that we have. A customer was confused and we were saying that, okay, what happens if I put a 5-inch or if how it changes if I put an 8-inch line? So that's the kind of calculation support that we can do. We can do it for different pipe diameters, and we can say that, okay, so if you are going for a 5-inch to 8-inch line, this is the amount of material that you can convey, and for this is the flow and pressure which is required. Now, just to sum up, we just talked about a few things. Just to sum up, I'm just concluding my presentation that we do have at Lescoco all the necessary the technologies, products for each and every applications of cement. Pneumatic conveying, specifically the conveying which we are doing from point A to point B or unloading applications, normally does not take pressure more than 1.5 bar. Considering the line losses, the bends, maximum 1.7, 1.8 bar. So we can have compressors which can operate at those, and these are actually will be saving a lot. Medium pressure machine connected, although it gives a bit of flexibility, but that will be a huge waste. I just showed you in one of the examples, almost 3.5 megawatt is being lost per year, which can be saved by a small investment, which gets paid back within 1.5 years. Screw blower, this is most important thing if I want you to remember that if the operating pressure is more than 0.7, 0.8 bar, it can save something like 35 to 40% of energy. So for all applications, specifically the burning applications in kiln, you can replace this and it will be an immense savings. Okay. For alternative fuels, because this kind of bypass arrangement has to be there because of the norms that we have for that, we do have the solutions. And last but not the least, we do have a solution for calculating pneumatic conveying requirements. So do share us your requirements, keep the basic details. We'll be more than happy to provide you with a calculation. So that's our message here. We want to work closely with all the cement plants in the country to reduce their operating costs, to increase their overall profitability, to reduce their carbon taxes. And just to give a perspective, just by, let's say, one of the kiln firing blowers, if you just replace that a screw blower with a Kylo blower with a screw blower, that is as almost equivalent to putting 1,000 to 1,200 trees, because that's the amount of the carbon footprint it absorbs. Okay, so it's also caring for the environment. Okay? So that's my final message. Thanks a lot, and thanks CII for again this initiative. Thank you. And if you have any questions, if you have got any questions, sir, you can directly mail it to me. I understand time is a bit of a constraint, or you can get in touch. I have left my personal details here. My email ID and my mobile number is mentioned here. So I will be more than happy to directly reach out to those questions.
Definitely question maybe is coming. IT team will connect to after this concluding session. So thank you, Saurabh-ji, the excellent presentation. And as you rightly mentioned about the whole detail, yes, we all know the globally presence of the Atlas Copco and in India also. And you have very much highlighted the minor thing like the fly ash bulker unloading, about what is the pressure required and how we can shift and how we can do the power saving, as well as you have touched the whole burning topic of cement industry, that is the chlorine bypass system and the AFR. This is the burning topic. Everybody, maybe if a participant is interested, after that, then definitely will contact to you how we can utilize this right size of particular blower and compressor in the chlorine, because this is very difficult to handle this fine material. And in the coming time, definitely in India, so much chlorine bypass system is coming, and this is more useful. Even we are searching for the same, how we can overcome this situation, because we came to know this is very difficult. So, thank you. You have concluded your presentation within the stipulated time. So this for also, and very nicely you have presented, you have given the through detailed analysis about the whole calculation, and you have mentioned around the 1 to 1.5 year the payback. This is also attractive for the whole consumer or the cement industry. Definitely you will touch.
Exactly.
So thank you, Saurabh-ji, and now we'll move as the next. So for Rohit Sharma ji, he also joined as a list regarding the how modernization can help in energy saving. So we all will hear you, and after that we'll conclude about this. So now, Rohit ji, now your time. Any issue? Rohit ji, I think you are.
So I am audible.
Yeah, yes, you are audible.
I am just sharing my screen. Then just please let me know. Kindly confirm after the screen this one.
Yeah, screen is okay. You may start.
Okay.
Yes.
So first of all, good afternoon, and thanks to CII and Chaudhary sir to give me the platform to present that how the energy efficiency is a play an important role for the auxiliary equipment, and in deeper to that, with respect to the depreciation of the plant and equipments, how modernization can play a major role for improvement of plant efficiency and their optimization. So basically, I'm taking care of the modernization portfolio in the drive segment and the motor segment. So we will touch upon the how the drives and motors are helping in such kind of the systems. So setting to the agenda of the this context, first is how this modernization is helping, and motor installed in the various cement applications where we have to touch and look upon. And as a subtopic we have taken two systems. One is the slip power recovery system for the slip ring induction motors, and the DC to AC conversion and the powertrain conversion, basically, which is a contains the motor and the drive upgradation of the complete system. So coming to the points, we have almost 60% industrial motor, which covers both DC to AC motors, and our this 60% equipments industrial motors, almost 30% motors are running on the VFD, which include DC to AC. And these are having the age system age near around 15 to 25 years. So by modernizing this equipments with respect to the technology, latest technology, we have a lot of scope for improvement in the energy and the optimization in the operation side also. And again, by forgetting that these systems contains 10 to 15% slip ring induction motor, which is basically operating on the constant torque as well as variable torque application. And 25 to 35% are the DC motor, which is operating to the DC drive, which is working on the applications like kiln and the cooler grid fans. So if we apply the concept of the modernization and the changing the technology, such kind of systems not only optimize the system energy, but also it optimize your operation by the in an efficient manner, because how the technology has changed generation by generation, which is quite evident to all of us in recent context. And it's by modernization, it helps to extending this lifetime within the recent equipment and enhance its performance by of aging asset by upgrading and retrofit and replacing with the latest technology. So these are the various options which we have in the system. So identified motors which we have identified and which we are looking in the cement segment. Just there are two kind of application which we have identified in the cement plants. Basically, first is the constant torque application and the variable torque application. So constant torque application where the slip ring induction motors are installed, like cement mill, vertical rolling mill, ball mill, crushers. And the variable torque application, which is the high voltage motor slip ring are installed, which are operating as of now through GRR or thyristor based system, or at some extent IGBT based system also. So which covers the raw mill fan, preheater fan, coal mill fan, vertical rolling mill, or sometime it calls as a CVRM fan also, baghouse fan, cement mill fan. So these are the application where we are supporting to our users or all the cement verticals by the slip power recovery system, by making it more energy efficient and matching with the recent updates and the technology. Coming on the DC motor side, which is installed in the uh, cement plants, which having the age near more than 20 years and about 30, near around 20 to 30 years. So these are the kiln application which is operating on the DC system in the most of the cement plants. Dynamic separator fan and the pyro section fans like cooler grate fan and the ESP fan, which is coming after the clinkerization unit. So coming to the ABB slip power recovery system, which is now basically a IGBT based technology, and it is based on our ACS 880 based drive platform. So setting on the agenda the brief about the slip power recovery system. It is basically a IGBT based technology which is used on the high voltage slip ring induction motor, and it is an external device which is connected to a rotor, and it recovers the power from the slip of the motor and feed it back to the grid. So in this way, traditionally we are operating this slip ring induction motor through GRR. So by controlling the speed and operating at their torque through GRR, there are lots of almost 15% of rated capacity of the motor energy is vested in the GRR. So that particular energy we are recovering by the help of SPRS and feed it back to the grid. So it looks like the system, SPRS system, where the motor is powered through the vacuum circuit breaker, and whenever their rotor voltage has been varied and it comes on the certain level, on the set like 690 volt or 415 volt, on that moment it takes the changeover and it is controlled by the GRR. So that particular energy is almost fed by the grid and is stepping up in the voltage level of 11 kV, 6.6 kV or 3.3 kV. So SPRS system is more sustainable to environment when it comes to the energy saving, and it recovers the power from the slip ring motor ranging 0.5 megawatt to 11 megawatt. And it is a best optimal solution when your slip ring induction motor operating on a particular speed range like 60% to 95% or 75% to 95%, because in this range we almost get the 10% to 15% energy saving or power recovery of slip ring induction motor. So slip power recovery system, its application. So here I have highlighted this slip power recovery applications are on the preheater fan, mill baghouse fan, coal mill fan, and the row mill fan. Apart from that, on this side there are the cement mill fan also used. So these are basically process fan which is operating on the high voltage slip ring induction motor on the speed range of 60% to 95%. So on this application we can use the IGBT based slip power recovery system. As a generation evolves, first it is operating through GRR, which is still all using. Second, it is using through thyristor based cascade system also, which is also used in the some extent, but it has on some certain limitation. And the recent one is the IGBT based SPRS system, which is having their own benefits. So coming to the next, 15% of the energy, maximum 15% of energy which is wasted as a heat loss, or if I relate it with a particular 3 megawatt motor, slip ring induction motor, it is almost 4.36 ton yearly loss or CO2 emission in the environment. Or if I convert it in the terms of energy, we are almost wasting or not gaining the approximately 1.8 gigawatt to 2 gigawatt power from this slip ring induction motor. And on the second side, GRR having the regular maintenance, and GRR system, it cannot be cope up with the recent digital technology, which is IoT based solutions. So how we have developed ourselves with respect to the technology? First, as a first generation, I can say for the speed control and process are GRR. Second was thyristor based system, which is has the limitation on the terms of obsolescence, which is an outdated technology, and the poor power factor maintaining at the motor hand. And whenever there dips comes, so there is a failures in the thyristor and harmonics, which is now a bigger constraint in the every cement plant or every process industry, which is it is maintaining near around 10 to 12%. And obviously pure sine wave we are not getting through the thyristor based SPRS system, and due to this there are issues arises on the rotor circuitry side, and there is no particular synchronization between the rotor circuit voltage level and the thyristor based IGBT level. So by coming on this point, IGBT based technology, it's a digital technology. Due to IGBT at the both converter and the inverter side, it is maintaining approximately unity power factor. It reduces the voltage dips also, avoid the failures, and maintaining almost unity power factor with 4% 4% harmonics. And due to IGBT and its added advantage, it maintains the smoother sine wave in comparison of thyristor based system. And addition of the digital synchronization unit has less failure or almost 0% failure for the rotor side to inverter side. So this is the difference or advancement of the SPRS technology. So what IGBT based SPRS system contains is basically dry panel, which consists of this complete LCL filter and the sine filter unit along with GRR circuitry. Feedback transformer, which is basically a step up transformer, which is feeding power to the grid in terms of 3.3 kV, 6.6 and the 11 kV voltage level. And the SPRS and GRR system, which is used for the changeover, and the isolators for the protection purpose. Here the sine filter which we are utilizing, it is reducing the stray capacitance of the system and giving much more smooth sine wave to the system. So what value proposition we are conveying to the customer, to the users like you? Slip power recovery system, it's recovering the wasted heat power which is getting wasted in the GRR in terms of 8 to 15% with respect to the operating condition of the system. Lower harmonics due to IGBT based system, there are less harmonics, less than 4%, which is we are getting. And by our engineering capability, we are making symmetricity in the both converter and the inverter side, which reduce the as an end result, which reduce the inventory burden on the end customer. And SPRS system, which is designed always in the N plus configuration, it means whenever there is any kind of a failure take place on the inverter side, so system can be run without any hassle or without any problem on the certain speed range. So that's kind of a footprint we are taking care on the while designing the SPRS. And one key advantage and special benefit that low voltage drives are used in this SPRS, so which is easily to maintain and which is quite reliable and well proven system in the cement industry. And obvious, these systems are coupled up with the IoT based digital solutions so that monitoring of the energy and the maintenance can be done very easily by digitally in a digital connect manner also. So there are the few examples which here I am sharing with you, where we have 6 various installation across the country, more than 100 plus with the IGBT base. But there are 4.6 megawatt system which we have installation, which is saving approximately 11.6 megawatt energy per year, and monthly basis it is reducing 0.21 tons 0.21 tons carbon emission. And the special point is it is installed on the 11,000 volt system, so motor rating on near around 11,000 kV, and above that range also we can go. Second, on the 5.6 megawatt system at the 82% speed, it is saving 13.2 megawatt energy and 0.29 carbon emission. And similarly, it is on the 11 kV system. 4.1 megawatt, it is saving 12.4 megawatt per hour, and it is roughly saving 0.26 carbon emission, and 6.6 kV is the voltage system. So if I say, if I am continuously using GRR on this in place of IGBT based SPRS, that much energy we are wasting, we are not able to recover from the system, from the slip power recovery motors, slip ring induction motor, sorry. So 3.3 megawatt system 10.2, 2.5 megawatt system 7.1, and 3 megawatt system 9.5. So these are typically operating on the 66%, 7%, and again 3 megawatt on 66% RP. Here we have internal publishment also, the SPRS which we have supplied to our one esteemed customer Wonder Cement on the preheater fan of rating 4.6 megawatt motor, 11 kV system. So SPRS is approximately recovering the 8 to 15% power of the motor capacity, which is near around 1.8 gigawatt to 2 gigawatt per year from the slip ring induction motor. And it is maintaining obviously unity power factor due to its own equipment. Here I just take a minute for briefing the specialty of the system also. It is basically a 4.15 volt system, and this power one which is saved by customer, they are feeding to a separate PCC system, and they are utilizing that power at some certain extent. So it means whenever we are having a fixed load and a fixed recovery power from a system like SPRS, we can utilize this power at somewhere else also, which is not possible with any other equipment or any GRR also. So this is the added advantage of the SPRS system installed on the process fan. So DC to AC powertrain converter system, when we discuss on the DC to AC powertrain converter system, it means a whole chain drive include motors. What are the solution, what we are looking in this context? So here identify DC application in the cement plants. So one is, obviously we all know, is a rotary kiln. Second is the clinker which is coming from the kiln side through cooler grade fan, and the other dynamic separator fan which is installed through the classifier sections. So with respect to the time and the technology, DC motor have their certain disadvantages also, which required regular maintenance on the carbon brush, high power consumption, and with respect to the time, manufacturing limitation of the DC motor. Power factor on the DC drive, power factor of the DC drives, which is 0.2 to 0.3. Efficiency of the DC drive is quite less in comparison of AC drives, and acts like a tip. It is having the harmonic contents near around 33% to 35% due to its power component. So there are some certain arguments comes when we are changing this technology. One is with respect to the DC to AC, how we have changed and how we developed ourselves. So one is predominantly people use the DC system because of this exact speed and torque behavior, whereas we are using DTC technology in our AC drives, which improves the torque response of the system. Field weakening, because DC motor have the two certain speed range. One is constant torque and one the field weakening range. So there are two speed ranges. So AC motor design can be done based on that maximum speed range with respect to the DC motor field weakening and speed range. And it supports the low mechanical inertia. DC drives have the 4-quadrant operation. So by using the active front-end drives, 4-quadrant system can be achieved, and speed can be supported by the drives by extending their field weakening area. And apart from that, this AC drives are taking care major point of the power factor, which is giving the maximum power at the motor side. So now coming to the advantages of the AC system, AC drive has the power factor of the 0.98, and if converter is completely active front-end drive like IGBT based, then power factor is almost nearer to unity. Efficiency of any DC system is typically same as the AC drives. So here if we compare as a complete package DC and AC drive and the AC motor, the overall efficiency of the AC drives and motor get improves. Accuracy in at the motor control side increase by our direct torque control technology, and by using the different pulse configuration like 12 pulse and 24 pulse system, harmonic content can be reduced by 12 to 15%. By using active front-end system, it can be reduced by 5%. And the AC motor, in comparison of a DC motor, it is having the less maintenance due to the removal of the carbon brushes, and AC motors are regularly manufactured. It is having the in the market. It is having the quite good availability.
Rohitji, if you can wrap up time up.
Yeah, sure, fine. And the power consumption is less, and these are having the high efficiency with respect to the we are supporting with the IE4, IE5 efficiency motors, premium efficiency motors also. So coming to the last, so if we use a AC motor and the AC drive system on the 1000 kilowatt motors, it is having approximately per year saving, which is near around 33 lakhs. So in this way, the DC system and the AC system get differs. And our offering on this part which is quite different compared to traditional method. First is drive, our ability offering, which is the Bluetooth display unit and the remote connectivity device, low voltage drive, medium voltage drive for the DC AC conversion system. And the motor side, IC motors, NEMA motors, and the high tension motors with motor sensors. So both can be monitored, and it can be events, and the faults can be recorded very easily in our portfolio. And we have complete cloud-based solution for these equipments. So this is from my side. Any question, please?
The highlighted about this constant torque motor and the variable torque motor. This is really you have explained in the, you can say the very, what is the required of the plant, the right kind of technology. And as you have highlighted regarding the IGBT based system, this is very much usable nowadays for the power saving. As you have mentioned, really 8 to 50% recovery of the advancement in SPRS technology. So this is really beneficial for all the industry, and definitely this will be helpful for the nowadays for the power saving, as you are mentioned for the unity power, also to help this using of SPRS system. So now we move to this retrofit energy efficiency, Mr. Anuragji. We are so time is now for the Anuragji. Please, Anuragji, now time for you.
Thank you so much. I hope I'm audible. I hope I'm clear.
Yes, you are audible.
Thank you, Mashankar Chaudhary ji. And hello to everybody on the panel. Hello to everybody attending today. My name is Anurag Kodagiri. I am from RITES India, and I will jump into the presentation right away. So just a moment, please. Is my presentation visible?
Yes. Sorry, it is loading. It is now.
Okay, so I'll quickly jump into the presentation. So we are RITES India. We are an Indo-German, fan manufacturing company. We're reaching almost 25 years in India since we have started our operations. Many of you here probably know us. Most of the cement plants know us. Most of the cement companies know us. Many of the people here know us. We are a company based out of, we're a 50-50 joint venture, like I said, company based out of Hyderabad in India. We've supplied to over 62 countries, 115 plus clients in the OEM and the cement market. We've so far given 36,000 fans as of last month. I think the number is into 37,000 now in the past 24, reaching the 25th year. We have two manufacturing units. One of them is located here in Hyderabad, in the outskirts of Hyderabad, with approximately 20,000 square meters and 350 people working for us approximately. And as you can see, that's my unit one in the picture. And we have a unit two, which we have acquired 2 years ago, which is again not too far from where I'm sitting right now, about 15 minutes, to cater to the ever increasing needs of the cement fan market. This is the range of parameters we do, typically from 100 watt column to 3150 if it's a single stage, or 5600 if it's two stage. Volume, as you all know, we've maximum done up to 20 lakh meter cube, but we can go up if there is ever a requirement. And we've given a highest efficiency of 89% in the industry. We do we do extreme applications in extreme environment, and so we use special steels and construction methods when it comes to our engineering. So these are the fans that we typically supply in a cement industry. I think I'd like to think we've listed most of them. As you can see, my models are just below the kind of fans. Fans are like the breathing lungs of any cement plant. And I do believe they take up almost 1/3 of the power, or a little more of the power consumption, which goes on in a cement industry. we are able to give you a really good quality product because we have certain SPM, or what we call a special purpose machine. Now, many of you know, so this is a Nodi machine, and using this, we for the impeller, we pretty much do the shrouds and the inlet cones. We are the only company in South Asia to boast of such a machine, and so what this does is it gives you the concentricity. It reduces the losses at the inlet cone, and it ultimately gives you a better efficiency when it comes to the fan. We have a laser cutting machine, which again gives you high precision, high quality when we manufacture the product in the end. When it comes to the hard facing aspect of it, and I think many of you would be interested, is because we are in an abrasion, industry where there's a lot of wear and tear. We have gone ahead and now we do laser cladding for tungsten carbide. For of course, for special application or special request, we are able to give this to the customers from our end. Um, why you have to come to rights is, I think, again, most of you know us. I'm not gonna stress too much on the fact our expertise, the team that we have, the highly skilled welders that we have with us, and the quick ROI, which is for the retrofit, which I'm getting there, is typically from 6 months to 2 years, is we are able to give you back the ROI on our fan. Uh, this again, I'll just run through it. Why is the wear and tear? What kind of areas do you find wear and tear? It's mostly in our equipment. I can speak for it's the fans, it's the kind of particulates that are present in the process which cause the wear and tear. Mainly areas like the casing surfaces or the blades of the impeller or the back plate. So these are the areas that are very critical and which contribute to the maximum wear and tear. So coming to the main point, we are retrofit is one of our biggest USPs. We were able to give customers great advantage with a quick ROI. And let's look at the kind of retrofits or the need for a retrofit. So in our understanding over the years, retrofit is pretty much summed up into three situations. The first one is, there is an existing impeller. We either do the trimming of the impeller, or we do the tipping of the blades. We add a little more to the blades, and we try to give you a better efficiency and try to do some power saving. The second situation is if the expected requirement of flow and pressure is unable to be delivered by the existing impeller, and you're looking to replace just the impeller. So that's what we do. We go ahead in your existing casing, we replace the impeller with our engineering, and we give you better efficiency and save power. The third situation is if the fan is really not efficient, and we replace the entire fan on the same existing foundation. Certain criteria or certain inputs that are really critical when we are selecting a retrofit requirement is, as you can see on the right. We put a picture of one of the in an old casing. We have we were able to put a brand new impeller, and these are some of the points on the left hand side that you need to be aware of for us to give you a really good retrofit solution. A replacement of old impeller with the new one. This is what mostly happens when we say it's a retrofit. Uh, we are able to give you a proven design so that the existing impeller sits in your the new impeller sits in your existing casing, and usually the throat gap should be 6 to 13% for us to achieve the best of the results. And also we look for the use of existing coupling and motor if that can be used and if that's the requirement of the customer. Now, some of the examples is what I have for you here is we have done a job in wholesome Bangladesh where we were able to maintain the same flow, same, the static pressure, but we were able to give them a power savings of almost 134 kilowatt hour, is what we are looking at. So and we've increased the efficiency from 82.8 to 87%, and this was done for a raw mill fan in Bangladesh for Wholesome. One more example for Wholesome in Algeria. We mostly put export projects. We've done a number of projects, thousands of projects in India as well. But we just wanted to highlight where we could get the maximum power savings. Here you could see we've almost given a 292 kilowatt hour of power saving, and increased the efficiency from 79 to 85%. This is a good example of something that we're really proud of. Is, as you can see on the left in the middle here. So for this particular cement mill fan in Nigeria, the impeller flew out of the casing. Luckily, nobody was injured, but we were able to send prefabricated blades from here to on the ground, do the cutting of send the shroud from here, do the welding on site, and then put it in the existing casing and run the fan. And we were also this was a very successful project for us. Again, here, we could save from 175 kilowatt to almost 200, and we were able to increase the tonnage per hour for the VCM from 380 to 400. Another example of the cement mill fan in UAE for Star Cement. We even got a letter of appreciation. Massive power savings, as you can see, 506 kilowatt from our impeller, and an increase from 75 to almost 82%. Another one for Dangote. So the examples can keep coming, but in short, we have the expertise, we have the know-how, the knowledge, if given a chance to. And I think these days it's all about power savings and sustainability, and RIDES is committed to giving you that, and to be able to help you go in that direction. Advantages of retrofitting with us, of course, there's an increased reliability with us. You save cost. As you could see from many of the examples, there's better performance. So there's improving in energy efficiency. And like I said, the ROI is from 6 months up to 2 years, depending on the fan. And we are contributing in not only increasing the productivity of the plant, but also the advantage with us of being in Hyderabad and boasting of 2 facilities, we are able to give you a quicker CTD than what the norm in the industry is. Thank you, gentlemen. I think I was pretty on point, quick about it, and I ran through it at a decent pace. If you have any questions, please shoot.
Thank you, Anuragji. The very nicely brief about this retrofitting, and this is the presently needs of the cement plant. After usage of AFR, the flow is required more with the same capacity of fan, but if we can do the tripping, and then we can enhance the flow, and it can fulfill the plant requirement. You have nicely explained about the Bangladesh example and other example. Definitely, the audience will take benefit. And
I'm sure we've done some work with JK Cement as well.
Yeah. So this is useful, and this is the need of the present system, and definitely it will help. So thank you. We have to wait for the question and answer. Now we have to move for the most reliable and excellent efficiency centrifugal blower for cement industry. As Chandramohanji is waiting for the same. So Chandramohanji, now time is yours. So this will helpful for the knowing about the blowers improvement and the plant reliability. So now Chandramohanji, you have to proceed.
Thank you very much, Chaudhary sir. I think I'm just sharing my screen. Probably got my screen.
Yes, it is visible.
Very good afternoon, one and all present out here in the seminar online, and looking a lot of participants in this particular seminar. I just would like to make a brief introduction about our GL Turbo. What is GL Turbo? Probably because I'm seeing since yesterday that a lot of eminent speakers from a lot of reputed and most trusted cement industries, people start speaking many new technologies and retrofitting and all sort of things has been flowing on. But of course, there is a technology for that, the blower as well. Most of the slides, of course, I have made deleted maybe about few slides because one of our friend in the same panel, Mr. Shaurav, has made me that he has made most of the points which is related to the efficiency point of view. So those things has been effectively already delegated by him. So that's the reason I just make it very precisely about my presentation. First, this particular GL Turbo is basically US-based company, which is having first developed blower in 2006, and even now, though we have more than thousands of installations across globe, still are the design and core components like what you're seeing right now. This the impellers and the gear and shaft, all cores are components. Still, it is manufactured in US, and we have a presence across globe. This I just would like to emphasize that in Houston we have a facility, and we have a facility in Leipzig, Germany, and we have a facility in China. And Boston, our head office is there in USA, and our CEO and most of the team members are sitting over here. And the Houston facility is having a reasonably a good amount of volume of people for manufacturing of the entire components. And Denmark, we have a R&D facility, and our ex-president and currently is working as a consultant. He sits in Denmark. And Wuxi, of course, we have a big facility in Wuxi as well in China. And this, most of the assembly and testing is happening in China. And here in India, we have an office in India for taking care of Indian operations in Bangalore. I'm heading that particular Indian operations. And coming to the blower technology, I think most of the cement manufacturers, the maintenance team who are working in the cement plants, who might be fully aware about the blowers because day in, day out, the air requirement for the kiln firing or maybe coal conveying or flash conveying or maybe for that, whatever is Mr. Saur was explaining. So most of the operations, their requirement of blower is everyday aspect. In this, I just broadly have categorized the technology which is available in the market. One is the right side, what you're seeing is about displacement, positive displacement blower, that is screw blower or maybe a twin lobe, tri lobe, or for that matter, there are many other technologies as well. And for the dynamic technology, the centrifugal technology, we have three different varieties. One is that the multi-stage, what you're seeing here, and the single-stage geared centrifugal, and the high-speed turbo drive. And mostly in the recent past, last 7 or maybe about 8 to 9 years, we have many cement industries started putting up this kind of a turbo technology, replacing the existing PD blowers on the account of energy efficient. Of course, this particular blowers, the turbo technology is highly energy efficient. Approximately compared to the PD blowers, it's about 30 to 50% energy efficient. Some cases we have a case study which is more than 57% also. Sometimes we are getting the reduction in the power. So in that case, so it's quite obvious that people will be tend to move on this particular technology. In my topic, I have made it very precisely that, of course, it's an excellent, efficient machine because of the technology which has been adapted. It is a turbo technology or maybe a centrifugal technology over the PD technology, the positive displacement technology. At the same time, the reliability is very, very, very important. Probably in this forum, those of the our privileged clients who are there in our forum itself, or maybe the participants, probably witnessed a lot many other issues which is happening through this the technology which has been adapted, that is turbo. I'm just going to brief about a couple of things where we are heading to and what is the result of it. Of course, this is just to give you a brief idea, our R&D center and manufacturing and all, and this is our testing facility. And here is I just wanted to push to that. If you just see the triangle of the two halves, the first half is particularly about the capacity and operational time. It is the PD blower and with respect to the turbo blower. So it is always the more amount of capacity if you go through. The more amount of capacity if you go through, then the PD technology is always not viable at all. And similarly, if you wanted to operate the blower for more amount of time, more than 8 hours, 10 hours, 24 hours for a plant, and cement plant, it's quite obvious that it is tend to operate throughout the year. Even barring the few days of the maintenance shutdown, the plant has to be in operational throughout the year. In that way, so the PD technology, which is more or less most of the cement plants wherever we have seen it, that they are almost tend to move towards the centrifugal technology, which we are witnessing everywhere. At the same time, what way it is the energy efficient way we can replace it. Of course, we are replacing for the sake of reduction in the CO2 as well as the reduction in the power and getting better what you call the less maintenance time as well as your lead time. Sorry, this the maintenance parts. Say for example, in PD blower you have a lot many maintenance parts you will have to maintain month on month or quarterly or maybe yearly or something like that. But this particular the turbo technology, it's quite obvious there is a very, very, very less maintenance parts. So in that way, you will be able to get away with a wonderful amount of less maintenance as well. And coming to this particular operational things of the particular centrifugal machine is this is basically a normal induction motor. It is nothing great or new technology. It's available like our friends from Siemens and ABB who are there, and most likely will be getting the motors from them. And the base is oil tank, and this is the particularly a core. This particular core is typically there is no limit on upper side for that. Of course, lawyer said there are limits for the in terms of commercial as well as technical. For the reason that if you're going through less, very small size, probably it may not be economical. But the upper side, there is no typically there is no limit at all. You can go up to 1 lakh meter cube per hour itself, and sometimes 1.5 lakh also. So as long as you have a requirement and it can be designed. But as far as the cement industry, let us focus more on this particular cement industry here. So here the maximum applications or most of the times what we are seeing is the kiln firing and conveying applications are majorly somewhere between 3,000 to maybe about some 7,000-8,000 meter cube per machine. So in that way, it is effectively this particular technology will be very well worked through and the efficiency is much, much, much higher compared to your existing PD blowers, if at all you have it. And this is one of the state of the art testing facility what we have it. And these blowers are tested both the test certificates ISO 5389 as well as the ASME PTC 13, which is available latest testing methods in globally. And this just to give you an idea how this particular core, whatever I've shown you in the previous slide, the particular core, how it will be in operational. What you're seeing, the green color is the IGV, and whatever seeing in the blue color is the variable, it's a VVD. And in between there is an impeller, and this is how the air passed through to the IGV and get excused and went through this particular VVD. And maybe in my next video, you may have a good idea how this particularly works. And this particular technology is very rugged gear technology. So this is very ruggedly and most reliably working for several years. For example, even our lifespan, what we are offering is about 20 years. So 20 years of lifespan is like whatever the friend previously was talking about the fans. It is almost a bit high technology compared to the. This is also use the impeller, but this impeller is slightly difficult compared to that as well. So next slide, probably this video, you will have a fair idea how this particular the core is working and how the gear is working. So this gear is always tied with the, engaged with the pinion. So this will be running the driven shaft, drive shaft. Both shafts are engaged with the impeller, and through which you will be able to get a maximum amount of flow. So here there is no typically the higher side there is no any limitations for the flow. Lower side, of course, as I said. And this machine is very high rise to surge. Why it is we are mentioning it? Normally the centrifugal technology or maybe the turbo technology is a lot of fear at the time of designing. They have to be very precisely designed the blower, otherwise whatever the back pressure or maybe sometimes it may go to surge. So this gear technology which will ensure that of course the surge is one very critical phenomena for centrifugal technology. It will always ensuring that whatever your major limit, it will be slightly higher than that. So obviously the machine will be always saved. That is one thing. Second thing is the proven technology which is available last 40-45 years. So there is no doubt about the performance of the equipment, and which is even 20 years before or 30 years before the machine which are running, maybe whoever it supplied, still it isn't running at a very good efficiency. There is no efficiency drop typically for even for 10 years, 20 years also, hardly nothing. And the inlet vein VVD is hardly requires a very any maintenance. It's only the oil which you need to be required to be replaced every 3 or 4 years. So that's it. So and the particular gears or maybe the particular impellers are customized and designed for each blower. So you can be able to typically you can work with any models. And second thing is the kiln firing, which is always required not this. And yesterday, some of our friend, I think from Siemens, one of our friend was telling that the kiln is effectively operating only at 6% efficient. Maybe it's not efficient. Maybe he was referring to the oxygen and the particular burning zone temperature or maybe fuel. Everything he calculated, and he was telling, of course, he started with 13% for some reasons, and later he come down to the 6%. Only the 6% effective firing which is happening inside the kiln. That is during yesterday's seminar. So in that case, so you can understand the effective amount of oxygen which is required. That means which is supplied by the blower. So this particular thing, kiln firing blower, I'm talking about, not about the other fans or whatever I'm talking about. So the at the temperature which is available in cement plant or maybe most of the cement plants which is located in the very tropical and hot area of pan India basis, even if you check it, very less plants are available in a cooler area. Most of the plants or maybe even a cooler area, the cement plants is tend to have a lot amount of heats and the dust as well. So this particular blower, the geared machines are very comfortable in terms of running this particular technology, which will be running comfortably for that those particular periods. And anyway, coming back to this particular technology, I wanted to tell you this. As of now, there are a lot of cement plants are using this high-speed technology, high-speed blower technology. This technology having a process of high efficiency and less starting current. At the same time, there are a lot many failures which facing by this cement plants, especially because of the dust and other things. So to avoid that, we have introduced a new hybrid technology, because whatever I've explained in the past is about the geared machine. At the same time, the induction, in place of induction motor, we have replaced with a PM motor, which will be running at a little more higher RPM, but still it won't be equivalent to that particular RPM of the high speed technology. I just want to, this particular entire seminar, I wanted to make sure that the differentiation between the high speed turbo as well as not to that extent of PD or maybe other blowers technology. The high-speed turbo and the gears are turbo, I want to narrate it. But here the GA means our model, the hybrid model, which uses the same gears and other thing. They employs the permanent vacuum motor, which is running only 6,000 RPM, not with the other technology, which is running more than 30-40,000 RPM. So the failure rate is very less, and VFD is the third generation VFD, so it will be a better efficiency. VFD efficiency is about 95%. And the footprint is small and weight also very less, and package noise is hardly 75 dB, so it won't be much of a noise as well. And the performance ratio, everything is very high. And this surge, as I explained earlier, during the high surge, we have almost 3 times better, and the service hours of almost about 10 years or maybe 1 lakh hours. And these are all the regular thing. And because of VFD and the combination of VFD as well as the gear, so you can have a wide range of the turn down ratio of 35 to 105%. So you can be operate, say for example, you have a 5,000 meter cube blower, which you can be operate easily. It's about 1,000 to almost 5,000 in that way. And DO control is nothing to do with the cement, but still, these are all the parameters which is available. And the PM hybrid motor is very, very particular, and it will not, it is operate only 6,000 RPM, is not going to be operate 30,000 RPM. Do I have time? I can, because I just wanted to explain about 3 things where the cement plant is going to be usage. One is about the kiln firing, where the O2 is very, very, very high requirement and appropriate time and level. So which will be ensuring by this hybrid model. And coal conveying and wagon unloading, this also is a very time limit, because this blowers maximum of 1.5 bar. So these 1.5 bar with the largest flow, which will be very well useful for your cement applications, all 3. And blower replacement upgradation also, we are very much interested. And this is going to be these are all the range which we have. You can just see that 2,300 meter cube. It's a smaller size for the GL model, that is a geared model, and maximum we can go up to 1,35,000 meter cube. This is the maximum level. And there is for a GA model, there is only 5 models. This also can start up to almost 1,500 meter cube to almost 13,000 meter cube. And this is just for an idea how it will be the lobe and the gear machine, which is looks like. And these are all few installations we have, which is available in India. And this is our regular style of working, which is consulting the client and select the blower technology, drive through the qualities, and supervise the installation startup. And this is how we run through. And thank you very much. You can just go through my contact details if you have any queries and questions, or maybe future also you can get me connected with these contacts. Thank you very much for the all the participants and chairman, session chairman. Thank you very much.
Thank you, Chandramohan ji. Very nicely elaborated about the how reliability is also important along with the adopting new technology. You know, if whole plant is running and if blower and compressor will trip, whole plant will be trip. So reliability part is really in the all area, but this when we are talking about the blower, compressor, and as you have rightly mentioned, highlighted about the kiln firing and this kiln filling. So this is very much needed, because if kiln firing blower trip, this is the whole heart of kiln will trip. So definitely this as was the energy saving as well as the reliability is the most important for the any of industry, especially cement industry. And you have highlighted about the hybrid technology and VFD also. You have highlighted 35 to 105%. Can we go up to the 120% also for the utilization of VFD?
Yes, it is possible. Yes, it is possible. Then you'll have to slightly compensate on the lower side. So the turn down has to be a little more higher. Maybe 40 plus, then it would be possible.
Yeah, okay. So then we may go for the question answer. Mr. Vinod, have you compiled the question answer? So maybe our panelist can reply accordingly if some question is there.
Should I read it, sir, or would you like to read it? Okay. Okay.
I think mainly 2 questions is there. Slip power recovery system is comparable to regenerative braking in electrical injection motor. I think this is being addressed to ABB.
Okay, I'll just repeat the question, sir, to ABB.
Yeah. Yeah.
Slip-over recovery system is comparable to regenerative braking in electrical locomotive and machines. So it is a question to ABB. Whether slip-over recovery system is comparable to regenerative braking. That's a question.
Basically, slip power recovery system, it's giving regenerative up to 30%. It can carry the 30% of the system. And for locomotive, it is not comparable because locomotive has a quite different application and cement users has quite different application.
Vinodji, any other question also there with you? Then my question with the Saurabh Chaudhary ji regarding this, as you have very much highlighted about the payback period ROI for 1.5 to 2 year. At present, what is the cost of this compressors, especially this oil-free compressor?
Sir, can you hear me? Hello?
Yeah, Saurabh, as we came to know, as you have very much highlighted about the ROI for the installation around 1.5 to 2 year. So
Yes.
what at present there is the message that more than 50% cost escalation is there for the this compressor and blowers.
No. Let me address this, please. See, when I'm making a presentation, I'm trying to generalize the thing. So it will be specifically on the model one. So let's say I took an example of 1000 CFM, which is a quite common thing for an unloading application. So if you take it in that way, it will be with the present setup that we have, it will be around 1.5 years or close to 17 to 18 months will be the payback.
Okay, thank you.
Even if you have a captive power plant and the power unit power rate is somewhere around 4 to 5 rupees, let's say, to be on a practical ground. Even with that, you will come around into 17 to 18 months for 1000 CFM. For bigger capacities, it will be even faster. So let's say you're talking about a bigger one, for 1500 CFM. Okay?
Yeah.
It will be even faster.
Rohit ji, one more question for you. As you are talking about the advancement of SPRS technology, so can this work with the less than 60% speed also? Because
Sir,
some plant requirement, sometime for starting in if a plant is disturbed, he has to run with the less than 50% of speed, and that time also really required for the power saving through SPRS system. So is it applicable or not applicable?
Sir, it is applicable. Basically, this factor depends on our rotor voltage. Lesser the rotor voltage, we have the wider operation speed range.
Anurag ji, as regarding you have very much highlighted about this retrofitting of this really required. So this retrofitting is you are changing only impeller or shaft or casing, everything.
Well, it typically depends on the requirement. I've listed 3 conditions. Most ideally, what we see is we only change we give the rotor, so which is the impeller, shaft, and but in some cases we also use the existing bearing housing. It depends. We have to analyze the situation. We have to see if our impeller is going to fit for the existing bearing housing. But typically we supply the whole rotor.
Okay. Any other question from any panel or any from participant? Vinodji?
No, sir. There is no questions. I think participants, you can drop in your questions in the chat box so that we can read it to the presenters.
Yeah, then okay, thank you for the nicely presented by all of the faculty, and I think you have given the whole thrust for the energy equipment. That is what was our topic for this for auxiliary equipment power saving, and you all are explained in very nice way. I think this is the very much useful for the all participants, especially for cement industry who joined today. This is really much beneficial, and definitely he will contact to you directly if any question answer and for the new requirement for the plant, because nowadays all the plant is going to modify, that is the capacity enhancement as well as the AFR incremental. So there is a much more requirement for all the system, and all you have presented very well, and this is really helpful for all participants. So thank you CI also for this choosing this topic for this. This is very much relevant in the present context of cement industry and other industry also. Thank you. I think we have concluded rightly within the stipulated time. Yes, Chandra Mohanji slightly get the less time because he has to pressure to complete his presentation within that time. So sorry, Chandra Mohanji, you have just concluded.
Thank you very much.
But we have justified within the stipulated time by the CI, so we have concluded within the time. Thank you all the panelists as well as the CII, Mr. Nodji.
Thank you.
Thank you. Bye.